Now, the latest development from Google that it describes as a state-of-the-art quantum computer chip.
Something just happened at Google's quantum lab, and CEO Sundar Pichai is shaken.
Extraordinarily important milestone. Last year we achieved something what's known in the field as quantum supremacy.
A powerful quantum computer was running advanced calculations when it shut down without warning. But before it did, it revealed something so shocking that Google is now scrambling to keep it quiet.
Willow is Google's newest and most powerful superconducting quantum computing chip.
Governments are stepping in, experts are raising alarms, and leaks suggest this discovery could change everything.
We're going to talk about quantum computing and all the ways that it will impact how we live, how we work, and how we play.
Did AI and quantum computing just cross a dangerous line? In this video, we will reveal how Google CEO broke down in tears after quantum computer shut down.
Quantum computers is a hardware question where it actually increases your ability to do much more than with an ordinary digital computer.
Google CEO's support for quantum computing. Google's CEO Sundar Pichai has always been a strong believer in quantum computing.
Quantum computing will break encryption as we know it today, but we can work around it.
Pushing Google to the forefront of this groundbreaking technology. Quantum computing and AI together are already a game changer, capable of solving problems that regular computers can't even process. When you combine the two, you get something incredibly powerful, a technology that can solve problems beyond what regular computers can even attempt.
Quantum computer operates by controlling the behavior of these particles, but in a way that is completely different from our regular computers.
Some experts, like physicist Michio Kaku, have warned that this combination might take things too far, to the point where humans won't be able to control it anymore. That hasn't stopped big companies from pouring billions into quantum research. Google, IBM, and Microsoft are all in a race to dominate this new era, knowing that whoever cracks the quantum code first will have an enormous advantage.
This is it.
This is a quantum computer.
This is a quantum computer.
Google's CEO, Sundar Pichai, has been one of the biggest supporters of this movement, pushing Google's quantum research forward at full speed.
Willow is Google's newest and most powerful superconducting quantum computing chip.
But recently, something happened that shook him to his core. Stay tuned. What you are about to find out will shock you. To understand why this is such a big deal, we have to know how quantum computers work. Regular computers process information using tiny electrical switches called bits. A bit can either be a 0 or a 1, which means that computers solve problems by flipping millions or even billions of these switches in a specific order. Quantum computers don't work that way. Instead of bits, they use qubits, which can be both 0 and 1 at the same time.
There, the bits are known as quantum bits or qubits, and rather than just being on or off,
this is called superposition, and it allows quantum computers to process huge amounts of information at once. Instead of checking one possible solution at a time like a regular computer, a quantum computer can look at millions of possibilities at the same time. That's what makes them so powerful. There's also something called entanglement, which is another strange property of quantum mechanics. If two qubits are entangled, changing one of them will instantly affect the other, no matter how far apart they are. This means quantum computers can share information in a way that's completely different from classical computers. Instead of sending data back and forth through wires or networks, quantum computers can instantly update information between entangled qubits.
a qubit can be held in something called a superposition, where it can be both on and off at the same time.
This ability could change everything, from data security to artificial intelligence. But quantum computing didn't just come out of nowhere. It all started with quantum mechanics, a branch of physics that completely changed how scientists understood the universe.
I see quantum computers as a way for us to probe the mysteries of nature.
In 1900, a scientist named Max Planck discovered that energy doesn't flow smoothly like water, but instead comes in tiny packets called quanta. This was the beginning of quantum theory, and it only got weirder from there. A few decades later, Werner Heisenberg came up with the uncertainty principle, which said that you can never know both the exact position and speed of a particle at the same time. Then came Albert Einstein, who along with two other scientists proposed something called the EPR paradox. They found that if two particles were entangled, they could instantly communicate with each other, even if they were light years apart. Einstein didn't like this idea and called it spooky action at a distance, but later experiments proved that it was real. At first, quantum mechanics was just a strange theory that only physicists cared about. But as scientists kept studying it, they realized it could be used to build a completely new type of computer. The idea of quantum computing was first proposed in the early 1980s by a physicist named Paul Benioff. Around the same time, Richard Feynman pointed out that regular computers struggle to simulate nature because the world operates on quantum rules, not classical ones.
When I look at the future and say, how do we drive improvements, quantum would be one of the tools in our arsenal.
He suggested that the only way to accurately simulate quantum systems was to use quantum computers.
The quantum computer, System 1, it sounds a little bit science fiction.
A few years later, Peter Shor developed an algorithm that showed how quantum computers,
or quantum computation. What I did hear from Feynman, it was a very interesting lecture,
could factor large numbers exponentially faster than classical computers. This was a big deal because modern encryption is based on the fact that classical computers take a long time to break large numbers into their prime factors. If quantum computers became powerful enough, they could crack nearly all existing encryption methods, which is why governments and intelligence agencies, including the NSA, started investing heavily in quantum research. Once the race to build a working quantum computer began, scientists started making serious progress. In 1998, researchers at Los Alamos National Laboratory managed to build a small 2-qubit quantum computer using nuclear magnetic resonance. It wasn't very powerful, but it showed that quantum computing was possible. By 2001, IBM had developed a 7-qubit quantum computer that successfully demonstrated some basic quantum operations. However, there was a big problem. Qubits are extremely unstable.
So this tiny little thing, right? This is the Heron chip. This is the 133 qubits that I am holding.
I've been fascinated with quantum computing since I first experimented with qubits.
Even the slightest interference from the environment, like heat or radiation, can cause errors in calculations. Scientists started working on ways to fix these errors, which led to the development of quantum error correction, QEC. One of the biggest breakthroughs in quantum computing came with the development of the surface code, a method that helps protect qubits from errors by spreading the information across multiple qubits. This made quantum computers much more reliable. Throughout the early 2000s, universities and tech companies competed to build bigger and more stable quantum systems. In 2005, the University of Innsbruck and the National Institute of Standards and Technology, NIST, successfully built a 5-qubit quantum computer that proved it was possible to scale up these systems. While 5 qubits might not sound like much, it was a big step forward. Quantum computers don't operate in a simple linear way, so even a small increase in qubits can dramatically increase their power. In 2007, researchers at Yale University made another breakthrough when they figured out how to make qubits more stable using solid-state systems. Instead of relying on delicate nuclear magnetic resonance techniques, they developed a method that used tiny superconducting circuits. These solid-state qubits were much easier to control and much less likely to be affected by outside interference. This breakthrough changed the game. Instead of being fragile lab experiments,
I think that you're probably going to see several different modalities focus on specific use cases initially, qubit.
Quantum computers were now moving toward becoming practical machines that could actually be used for real-world applications. Companies like Google and IBM saw the potential and started investing heavily in quantum computing research. Google, in particular, made a huge push under the leadership of Sundar Pichai. The company's quantum research team worked on creating a powerful quantum computer that could perform tasks no classical computer could match. Then came the moment that shocked the world. Google announced that its quantum computer had achieved quantum supremacy, meaning it had performed a calculation that would take the most powerful classical supercomputer thousands of years to complete. This was a historic achievement.
But I think the combination of AI and quantum will help us tackle some of the biggest problems we see.
Proving that quantum computers weren't just a theoretical idea anymore, because they were real and they were more powerful than anything that had come before. But that victory didn't last long. Something happened that made Google take a step back. The same power that allowed quantum computers to solve problems at incredible speeds also made them unpredictable. scientists started noticing strange results, calculations that seemed impossible, results that changed when they shouldn't have, and patterns that didn't make sense. Some researchers began to worry that quantum computers, when combined with advanced AI, might start operating in ways that humans couldn't understand or control. Michio Kaku's warnings about AI and quantum computing suddenly seemed more relevant than ever. The idea that technology could evolve beyond human control was no longer just science fiction, it was starting to look like a real possibility. Google's quantum team began reassessing their research, and suddenly there were rumors that Sundar Pichai was no longer as confident about the direction they were heading. The researchers were uncertain about the outcome. Don't miss the next scene where things get even more interesting. The uncertainty surrounding quantum computing. This uncertainty left researchers in a strange position. On one hand, Google had proven that quantum supremacy was real. On the other, they had no idea what would happen as quantum systems became more advanced, especially when paired with artificial intelligence. Meanwhile, outside of Google's labs, something just as shocking was happening. In 2010, researchers at the University of Science and Technology of China successfully achieved quantum teleportation. No, they didn't teleport physical objects like in science fiction, but they did something just as incredible. They transferred the quantum state of a particle across a distance of 10 miles. This was huge because it proved that quantum networks could become a reality. Traditional internet communication relies on signals traveling through wires or radio waves, which can be slow and vulnerable to hacking. But quantum teleportation allows information to be transferred instantly between entangled particles, no matter how far apart they are. That means completely secure, lightning-fast communication. Governments and tech companies immediately realized what this meant.
Google researchers have achieved an incredible breakthrough in quantum computing.
If quantum networks became mainstream, they could completely change cybersecurity, global communications, and even how the internet itself functions. While China was making huge strides in quantum teleportation, Google wasn't slowing down either.
This gets positioned right here on the fridge.
Karina Chow, Chief Operating Officer of Google's lab.
In 2013, they teamed up with NASA to work on the D-Wave 2 quantum computer. This wasn't just some research experiment, it was a serious attempt to push computing beyond anything classical computers could handle. The D-Wave 2 was set up at NASA's Ames Research Center, where it was supposed to solve problems that regular computers would struggle with for years. But then, out of nowhere, the US government stepped in and put quantum computing research on hold. The reasons weren't entirely clear, but security concerns were a major factor. Quantum computers have the potential to break encryption, which means that any government secrets, financial transactions, or private data protected by today's security measures could suddenly be vulnerable. If the wrong people gained access to this technology before there were safeguards in place, it could be disastrous. As a result, the D-Wave 2 was left in an awkward state. It was operational but underused. Google's Ames Quantum Artificial Intelligence Lab, which had been created specifically to advance quantum research, suddenly found itself stuck in limbo. The government shutdown had a serious impact on quantum computing. NASA, which was supposed to be working closely with Google, was unable to properly test the D-Wave 2, meaning months of progress were lost. Google itself couldn't fully access the system either, which meant that the groundbreaking research they had planned was put on pause. Scientists working on the project were frustrated because, in a field like quantum computing, even a small delay can set back progress significantly. Unlike classical computers, you can't just turn a quantum computer off and back on like a regular laptop. Once these systems are shut down, rebooting them is a complicated and expensive process. But despite the setbacks, Google's researchers weren't ready to give up, and their persistence paid off. In 2019, Google made history once again when they announced that they had achieved quantum supremacy with their Sycamore quantum processor.
Google officially announced Wednesday it has achieved quantum supremacy. The tech giant says its quantum processor.
This was proof that quantum computers were now more powerful than even the most advanced classical supercomputers. The Sycamore processor solved a complex mathematical problem in just 200 seconds. For comparison, the world's fastest supercomputer would have needed thousands of years to solve the same problem. This sent shockwaves through the tech industry. If quantum computers could already outperform classical ones in certain tasks, it was only a matter of time before they became mainstream. Google's success didn't go unnoticed. IBM, Microsoft, and other tech giants immediately ramped up their quantum research, determined not to be left behind. IBM, in particular, made a bold move in 2020 by unveiling the IBM Q System 1, the world's first fully integrated commercial quantum computer. Up until that point, most quantum computers were strictly research tools used by universities and tech labs. But IBM Q System 1 was different since it was designed for businesses. This marked a turning point in quantum computing. It was no longer just a futuristic concept. It was becoming a practical tool for real-world applications. Governments and private industries quickly took notice. Funding for quantum research skyrocketed, with countries around the world recognizing how important this technology could be for national security, finance, and scientific discovery. Quantum computing research centers popped up everywhere, bringing together experts from academia, industry, and government agencies. Everyone wanted a piece of the quantum revolution. As all of this was happening, scientists were also looking at a much bigger picture: the search for extraterrestrial intelligence. For years, researchers have struggled with the Fermi paradox, which asks a simple question: if intelligent life exists in the universe, why haven't we found it? Back in the 1960s, scientists started scanning space for radio signals from alien civilizations. But so far, the results have been disappointing. Some physicists now believe that aliens, if they exist, might not be using radio signals at all. Instead, they could be using quantum computing and advanced physics to communicate in ways we can't yet detect. One of the more interesting theories is that extraterrestrial civilizations could be using black holes as quantum supercomputers. A group of physicists from Germany and Georgia suggested that if a civilization were advanced enough, it might harness the power of black holes for massive-scale quantum computations. The extreme gravitational forces and quantum effects near a black hole would create the perfect environment for powerful calculations, far beyond anything we could achieve on Earth. If this is true, then some of the unexplained cosmic signals we've detected might not be random noise, but evidence of alien quantum technology at work. This idea ties into another theory about Hawking radiation, which was first proposed by Stephen Hawking. He suggested that black holes slowly emit energy over time in the form of Hawking radiation. Some physicists now believe that if aliens are using black holes as quantum computers, their calculations might leave traces in this radiation. Two researchers, Jedvali and Zazosmanov, even proposed that high-energy neutrinos might be byproducts of these alien computations. Neutrinos are incredibly difficult to detect because they barely interact with matter. They pass right through planets, stars, and even people without leaving a trace. But if aliens are using neutrinos for communication or computation, then we might have a way to detect them. The Ice Cube Neutrino Observatory in Antarctica is one of the key facilities looking for these signals. If it ever picks up an unusual pattern of high-energy neutrinos, it could be the first real evidence that advanced extraterrestrial civilizations exist and that they're using quantum technology far beyond our understanding. If aliens are using black holes as quantum supercomputers, that would explain why we haven't been able to detect any signals from them. This idea fits perfectly with the Fermi paradox, which is the question of why, in a universe so vast, we haven't come across clear signs of extraterrestrial intelligence. One possible answer may be because advanced civilizations don't rely on outdated communication methods like radio waves anymore. Think about it. Humanity has only been using radio waves for about a century. If a civilization is even a few thousand years ahead of us, they've probably moved on to something way more advanced. Instead of sending weak signals across space, they could be using quantum communication, something we don't yet have the technology to detect. This ties into the L parameter in the Drake equation, which estimates how long civilizations actively send out detectable signals. If civilizations only use primitive communication for a short time before upgrading to something undetectable, that could explain why space seems so quiet. Maybe the universe isn't empty, maybe we're just listening with the wrong tools. While scientists are still searching for extraterrestrial life, some experts are more focused on what's happening right here on Earth. Michio Kaku, a well-known theoretical physicist, has spent years breaking down complicated scientific concepts for the general public.
Different concepts, and yet we believe in our heart of hearts there has to be a master theory out there.
In his book Quantum Supremacy, He talks about how quantum computing is reshaping everything from artificial intelligence to space exploration. During a recent podcast, he brought up one of AI's biggest weaknesses. It has no built-in way to tell the difference between truth and lies. AI chatbots and search engines can generate text, summarize information, and even answer complicated questions, but they can't verify if something is actually true. Kaku believes quantum computing could fix that. With the power to process and cross-check vast amounts of data instantly, quantum AI could be used to verify facts with unparalleled accuracy. That sounds like a game changer, right? Well, there's a catch. While this kind of technology could be used to fight misinformation, it could also be abused. Governments and corporations could control information more easily than ever, filtering out anything that doesn't align with their narrative. Instead of helping people get closer to the truth, quantum AI could be weaponized to manipulate public opinion in ways we can't even imagine yet. What you're about to hear will blow your mind. Problems of quantum computing. Quantum computing, like any powerful technology, is a double-edged sword. On one side, it has the potential to solve problems that classical computers can't handle. On the other, it opens up new risks that we've barely started to understand. AI has already changed the way we interact with technology, from deepfake videos to AI-generated news articles. At first, these tools seem harmless and fun even, but now deepfake technology is being used to spread fake political messages, and AI-driven misinformation is making it harder to tell what's real and what's not.
First, because this demonstration video has been crafted using the lip synthesis web application.
Even in law enforcement, AI isn't always a good thing. Predictive policing tools, which use AI to analyze crime patterns, have been accused of reinforcing biases instead of preventing crime fairly. In finance, AI-powered trading bots have caused sudden market crashes by making rapid, unpredictable trades. If quantum computing makes AI even more powerful, the risks will only increase. Governments and tech companies are rushing to put safeguards in place, but in a race this fast, it's hard to predict what will happen next. While some scientists are focused on AI and security risks, others are still working on building the ultimate quantum computer. Right now, researchers all over the world are trying to create a fully functional, large-scale quantum system. The problem? We're not quite there yet. Even though quantum computers have already proven their superiority in specific tasks, scaling them up is a whole different challenge. Scientists are exploring different approaches to get there. One method, called gate-based quantum computing, relies on precisely controlling individual qubits to perform calculations.
Arrival of quantum computers could be even more historic than...
Another, called adiabatic quantum computing, uses quantum annealing to solve complex optimization problems. Both have their strengths, but neither is perfect. One of the biggest challenges in quantum computing is stability. Qubits are ridiculously sensitive to their environment because any slight interference can cause them to lose their state, making calculations unreliable. This is why quantum computers need to be kept at ultra-low temperatures, close to absolute zero. Without that extreme cooling, qubits become too unstable to work properly. But cooling these systems is expensive and requires highly specialized equipment, making it hard to scale up. Error correction is another massive hurdle. Unlike classical computers, which can easily detect and fix errors, quantum computers struggle with this. Even the smallest mistakes can mess up an entire computation. Scientists are trying to develop better error-correcting codes, but it's a slow process. Despite these difficulties, companies like IBM, Google, and Microsoft are pouring billions into quantum research, hoping to be the first to crack the code and build a large-scale, reliable quantum machine. While researchers are dealing with the technical side of things, software developers are working on new quantum algorithms to make the most of this technology. Governments worldwide are also jumping in, funding national quantum initiatives to stay competitive in the race. The potential applications for quantum computing are huge, since everything from machine learning and cryptography to drug discovery could benefit from quantum processing. Pharmaceutical companies are already testing quantum models to simulate molecular interactions, which could lead to breakthroughs in medicine. The more progress researchers make, the closer we get to seeing quantum computing in real-world industries. One area where quantum computing could have a major impact is space exploration.
To a deep dive into how quantum computing is revolutionizing our understanding of the cosmos.
Right now, space agencies rely on traditional supercomputers to run complex simulations for mission planning. But these computers, no matter how powerful, still have limitations. Quantum computers, on the other hand, could handle calculations that would take classical supercomputers weeks or even months to complete. That means better models for predicting cosmic events, improved trajectory planning for interplanetary missions, and faster simulations of space environments. NASA and other space organizations could use quantum algorithms to optimize spacecraft routes, reducing fuel consumption and making long-distance space travel more efficient. Predicting space debris movements is another huge challenge that quantum computers could help solve. The growing amount of junk orbiting Earth poses a real threat to satellites and future missions, but with better predictions, we could avoid potential collisions more effectively. Beyond practical applications, quantum computing could also help us understand the fundamental laws of the universe. Simulating black holes, dark matter interactions, and even the origins of the cosmos could become much more precise with quantum-powered calculations. Some researchers believe quantum simulations could reveal answers to some of physics' biggest mysteries, which are things we can't test in a traditional lab setting. The next part of the video will change everything you are thinking: quantum computing and the future of cryptography. As quantum computing pushes the boundaries of what's possible, it's also shaking up one of the most important areas of technology, which is cryptography.
Unless we get some post-quantum cryptography post-haste. So how close are we?
For decades, sensitive data has been protected by encryption methods that rely on the fact that classical computers struggle with certain mathematical problems. Whether it's government secrets, financial transactions, or even space mission communications, encryption is what keeps this information safe. But quantum computers could change that. Most modern encryption relies on the difficulty of factoring large numbers. Classical computers take an impractical amount of time to crack these codes, which is why encryption methods like RSA and AES have been considered secure. But a powerful enough quantum computer, using something like Shor's algorithm, could break these encryptions in a fraction of the time. That means everything from military communications to personal banking details could be at risk. Space agencies, for example, depend on secure channels to send commands to satellites and rovers. If those signals were intercepted or tampered with, it could lead to mission failures or even national security threats. That's where quantum cryptography comes in. Instead of relying on traditional number-based encryption, quantum cryptography uses the principles of quantum mechanics to create secure communication channels. Techniques like quantum key distribution, QKD, make it nearly impossible for hackers to intercept data without being detected. The moment someone tries to eavesdrop, the quantum state of the system changes, alerting both parties to the breach. This could make future communications, whether between Earth and deep space missions or within financial institutions, far more secure than anything available today. While encryption is one of the biggest concerns, quantum mechanics could also change how we explore space. Scientists are already looking into ways to use quantum effects like tunneling and entanglement to develop new propulsion technologies. Quantum tunneling, for instance, allows particles to pass through barriers they wouldn't normally be able to overcome. If engineers can harness this effect on a larger scale, it could lead to faster and more energy-efficient spacecraft. That means less fuel consumption and possibly even new ways to travel across vast distances. The grand finale is coming. Get ready to be amazed. Propulsion isn't the only thing quantum mechanics could improve in space travel. Quantum sensors could provide more precise navigation for spacecraft, helping them avoid obstacles like space debris. These sensors could also be used in deep space missions, allowing probes to detect and measure gravitational fields with much greater accuracy. In the long run, this could lead to more advanced mapping of unexplored planets and moons, giving scientists a clearer picture of what's out there. While space agencies look at quantum advancements for exploration, the military is also paying close attention. Quantum computing has the potential to completely change military technology, from battlefield strategy to intelligence gathering. Encryption breaking is just one aspect. Quantum computers could also simulate nuclear reactions, optimize logistics, and even enhance AI-powered defense systems. With quantum simulations, military scientists could design stronger, lighter materials for armor and weapons. AI systems powered by quantum computers could analyze massive amounts of battlefield data in real time, helping commanders make faster and more accurate decisions. One of the biggest concerns, though, is the potential for quantum computers to break existing security systems. Governments, banks, and major corporations all rely on encryption to protect their most sensitive data. If quantum computers become advanced enough, they could render today's encryption methods useless. That includes everything from classified military documents to financial transactions. Cryptocurrencies, which rely on cryptographic security, could also be at risk. If someone figured out how to use a quantum computer to break blockchain encryption, it could cause massive disruptions in the financial world. That's why researchers are racing to develop post-quantum cryptography. Instead of relying on traditional number-based encryption, post-quantum cryptography focuses on creating mathematical problems that even quantum computers would struggle to solve. Governments and cybersecurity experts are testing different quantum-resistant encryption standards to stay ahead of the threat. But switching to quantum-safe encryption isn't as simple as flipping a switch. It requires a complete overhaul of existing security infrastructure, which means banks, tech companies, and government agencies will need to upgrade their systems before quantum computers become powerful enough to pose a real threat. The risk isn't just limited to encryption and privacy. Scientific research could also be affected. Quantum computers have the potential to revolutionize fields like drug discovery, climate modeling, and materials science. But with that power comes the risk of data manipulation. If someone were to gain unauthorized access to quantum simulations, they could alter research findings, disrupt experiments, or even sabotage critical discoveries. This is why scientists are now focusing on developing secure frameworks to protect quantum-generated data from being tampered with. What do you think is the future of quantum computing? Let us hear your thoughts in the comments section. Do not forget to like this video and subscribe to our channel. Click on the next video displayed on your screen. You will enjoy it.